Okay, section 5.7, last section in chapter 5. The first part we're going to look at is Eulerizing graphs. Just to reiterate what we've been talking about this chapter, we're doing routing problems. So, if you can't travel every edge once, which means we don't have a Euler circuit or path in the graph, then we need to retrace some edges to meet the exhaustive requirement. So, what we're going to do here is we're going to take a graph that is not a Euler circuit and we're going to create one by adding what they call duplicate edges. Okay, so we've got a couple rules here that we have to follow. As always, there's always some kind of a rule or something to follow. So we've got a process of Eulerizing a graph. The first thing we want to do is we want to identify all of the odd vertices. Because remember, in a Euler circuit, we don't want any odd vertices. So we're going to circle the ones that are odd, or you can take a highlighter to them, whatever you want to do. I'm going to highlight them. You're going to highlight the ones that are odd right now. Okay, so we're going to identify those. We're going to pick any two odd vertices, and we're going to duplicate the shortest path between them by adding an extra edge. Remember, multiple edges are just more than one edge that connects two dots. So, our only rule here is we have to duplicate an existing edge. We cannot create anything new. So, I will show you what that means in our first example here. If we have more than two odd vertices after we do step 2, so we're going to take it one step at a time. We're going to continue to repeat step 2 until we get rid of every odd vertice within our graph. Okay. Step 4, try for optimal Eulerization. We want to try to do this in the least number of multiple edges possible. Okay. And then finally, step 5, Fleury's algorithm to actually find the Euler circuit on this new graph. I'm not requiring that you do that on the test for this. Therefore, I think we're going to skip that last step. I just want us to actually create a circuit or a path. Yeah. I don't actually have you identifying the path of the circuit on the test, so we're actually going to skip step 5. But let's move on here. Okay, so our first graph here on the left, that goes A all the way up to L. So our first step is we want to highlight, circle, whatever you want to do to identify all of your odd vertices right now. So let's look. A has a degree of 2, B has a degree of 4, C has a degree of 4, D has a degree of 2, E is odd. That's a no-no. Okay. F is still good. That has 4. G is good. That has 4. H has 5. So there's a no-no. I is 2. J is 4. K is 4. And L is 2. So this one should be actually simple. We have 2 odd vertices. Okay, so now we want to create multiple edges that connect E to H. Therefore, it will turn them into even vertices. So what I mean by that is, I'm going to take a red pen here. I can't just draw a line that goes like this. In all reality, that's perfect. E is now even. I added an extra edge there. So E now has a degree of 6 and H has a degree of 6. This is a no-no though, because there isn't already an existing edge there. There is no edge that connects E directly to H. So you can't use that. So let me go ahead and erase that. We have to use edges that already exist to connect E to H. So the easiest that I can see is as I go across the center here, I can now create multiple edges. So I can go from E to F. When I do that, E now becomes even, F becomes odd. Okay, so F is now a problem. But if I start at F and go to G, F now returns back to even. There's 1, 2, 3, 4, 5, 6 edges coming off of F now. G, however, is odd, but now I can connect G and H, and G has 6, and H has 6. Again, go back and check yourself. Make sure that the ones that you added are going to make this a Euler circuit. So, A has a degree of 2, B is 4, C is 4, D is 2. E is now 6 because we added an edge. F is 6 because we added 2 edges. G is 6, we added 2 edges. H is 6 because we added 1. And we didn't do anything with I, J, and K, so we're just 2, 4, 4, and 2. They're all even. We now have a Euler circuit. Okay. Let's go on to this one in the center, A through F. Again, identify all of your odd ones first. So we've got E and C. Okay. Again, you can't draw a line that goes from E to C to create those even degrees, because there's not already a line there that exists. There's no edge that connects E to C. So, I've actually got two options here, two optimal options, because again, you want to create the shortest path possible to connect the 2 points. So, I can loop it from C to F and F to E, or I can loop it inside C to B and B to E. Either way works. So now C has a degree of 1, 2, 3, 4, because I added an extra one. Even though B was even, I went into B and then back out of B, so it is still even because it has now a degree of 6. And E has a degree of 4. And again, we didn't touch F, so it's still 2, D is still 2, and A is still 2. I'm going to do one more with you, and then you can go ahead and try the other ones on your own and then check yourself. So, this big old square of a mess right here. Let's see. Odd, 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 odd. It looks like all of these middle ones on the outside edges are all odd. Okay. My biggest tip when you have a graph like this is to go ahead and start on one of the outside edges of one of your edges. So, I'm going to start here at the top, okay? If I connect these two, that makes this even and this even, okay? Both of these. This is now 4, whoops. My marker. This is now 4 and this is now 4. Okay, I don't want to mess with those anymore. But somehow, this is 2, sorry. Somehow I need to now make this even. So the way we get away with that is we're going to loop it to the corner. So this is 4. This is now odd though. I've created 3 here. But I can now connect this to here. So this is now 4. And this is 4. You see the pattern that's starting to emerge here. I can connect these two odds together. That makes this 4 and this 4, which means I can skip this one. It's already even. Start here, connect these two. So we've got 4 and 4. We've got to do the same thing on this funky corner here, like we did up in the top right. So I've got to go to the corner. That's 4. That makes this odd. but if I connect this to this now, that changes this to 4 and makes this even, and then connect these last two, and that's 4 and 4. And again, all of these inside ones are 4, 4, 4. They're all 4. They're all like that little intersection in the middle of the road. Okay. All right, go ahead and try the next 3 on your own, and then you can switch back over to me, and we will check it. Okay. In this next graph, C is odd, D is odd. That's it. Easy fix. There's already a line that connects C to D. So all we need to do is take our marker and go C to D. So this is now 4, this is 4. A was 2, B was 2, E was 2, F is 2, and G is 2. This little tiny square here was pretty simple. If you look, we've got odds again just in the middle of the outside edges. But we don't have an odd number on the outside. So our easy fix is here. Whoops. We'll just do it with the highlighter. Here, here, and here. So again, that makes this 4, 4. This is 2, 2. Both of these are now 4. Both of these are 4. This is 2. Both of these are 4. This is 2. And then again, everything on the inside are 4s. Okay. Last one for Eulerizing. Let's see, we've got 3 here, and 3 here, and 3 here. That one's even, even. 3 here. That's 4. This is 3. This is 3. This is 3. This one's 3. 3. 3. 2. I don't think I missed any. Okay. All right. There really is no easy attack spot for this one. I'm going to try here and here first. Remember, because this one here was even, because this point right here, because this point right here was even, I need to go into it and out of it to keep it even. I cannot just go into it. So I went in and out. So this one now has 4. This one now has 6. This one now has 4. So I don't want to touch those anymore if I can avoid it. And I'm just going to kind of follow around the outside edge now. So here's 4 and 4. Connect these two. We've got 4 and 4. Just like we did up in that square one right above this, we're going to do that roundabout edge thing here. So we've got 4, 4, and 4. Again, because this one was already even on the outside corner here on the left, it has to go in and out to keep it even. And then we can loop this one up, and that makes that 4 and 4. Now, again, yours does not have to look exactly like mine, okay? As long as you have turned all of your odd vertices to even, and you've kept all of your even vertices even, you're good. So let me go back and check and make sure I didn't touch anything else here. This is 4, this is 4, this is 2, 2, 2, 4, and 2. Okay. we've got one more. Last concept, semi-eulerizing. Okay, so all this is we are now going to create a Euler path instead of a Euler circuit. So we still have to do the same process as we did Eulerizing, except where they tell us we're going to start and where they tell us we're going to end, we're going to leave odd. We're not going to want to mess with. So we still need to identify all of the odd vertices, except start and finish. I wouldn't even mess with start and finish. So right next to here, I want you to put except start and finish, or start and end, I guess. Okay, those are the only 2 points that you don't want to mess with. Everything else is the same. So step 2, we're going to pick any of the 2 odd vertices and we're going to duplicate the shortest path between them by adding multiple edges. If we have more than 2 odd vertices that remain after we do step 2, we're going to continue to do it and repeat it over and over again. Again, here is start and end vertex must remain odd, but more edges can be added to make them a larger odd degree. So you can use your start and end, but it's kind of like your even ones. If you go into it, you also have to come out of it, so you keep it as an odd vertex. Okay, we're going to try for optimal semi-eulerization. And again, we're going to skip step 5 because I'm not requiring you do it on your test, and I don't see them requiring you to do it on your state exam. So let's scroll down here. Okay, so let's identify all of our odd. So this one, I'm going to skip the start one because it needs to be odd. Okay, so we've got all of these edges. Again, I'm going to skip your end because it's supposed to be odd. Okay. So I'm going to connect these 2 right away. That makes this 4 and 4. Okay. And then kind of like we did with the Eulerization one, that third graph that we did, where we had to connect to the corner and back. So that makes this 4, 4, and 4. Again, I can go ahead and do that here as long as I go in and come back out to keep it even. And then I'm going to do the same thing up here. This is 4, 4, and 4. Okay. Next one. Start needs to remain odd. So we've got all of these odd. End needs to remain odd, so I'm not going to mess with that either. I always like to start somewhere near the start or the end and start connecting my points. So I'm going to go up to the start here, connect these 2, so that makes that 4 and 4. I can skip that one because it's already even. Connect these 2, so we've got 4 and 4. Here we go with that around the corner thing again. So we've got 4, 4, and 4. Skip over my end one because I want to remain odd here. Go around the corner here. So we've got 4, 4, and 4. And connect these 2, and we've got 4 and 4. They do get easier as you do them, I promise. Okay. Let's see. Next one. This is odd. 1, 2, 3, 4. This one's odd. 1, 2, 3, 4, 1, 2, 3, 4. That's it. So this one should be a pretty simple one. Again, you cannot connect those 2 directly because there is no edge that connects them already. So we do have to use a point in the middle. So that makes this 4. That changed this to 5, but if I leave that point again and continue on, that makes this 6 again and turns this into 4. And again, your start and your end must remain odd, so I did not touch them. So here's some practice. Go ahead and try these on your own, and then come back, and you can check yours against mine. Okay, when I identify my odds, okay, remember this is semi-eulerizing, so I need to leave my start and my end as odd. So I've got an odd one here and an odd one here. Remember, loops count as 2 because there's an in and an out with the loop. Okay, so this one should be pretty simple. Okay. If I connect to the middle, that changes this to 4. And then if I use it and go back up, that changes this to 4 and keeps that as a 6 because we went into it and back out of it. In the middle, let's see. Start is odd. This one is odd. 1, 2, 3, 4. It looks like this one is odd, this one is odd, and this one is odd. Okay. These ones are pretty simple as well. We already have a line that connects here, so we can just duplicate it. So that changes that to a degree of 4, and changes this to a degree of 4. And there's also a line that connects these 2 points, so we can just duplicate it. That changes this to 4, and this to 4. Okay. Over here, let's see, 1, 2, 3. This one is odd, that's even. That's even. This is odd. Okay, this is one of the ones where in order for it to be optimal, we really should go through either the start or the end point here. Okay, and that's okay. Again, in order for you to use the start or end point, you just have to make sure that once you make it even, you turn around and you make it odd again. So, as I trace from here to here, that makes this 4, but that changes this into a 4 as well. But then if I leave the end and go back up to this point, that changes this back to an odd, which is what we wanted, and it changes this to a 6, so it is now even. Last ones, and we are finished with chapter 5. This time we're going to Eulerize, so everything needs to go to even now. So I've got an odd here and an odd here. So I would just trace it straight through that middle and use that middle point as a connector. So we've got 2, 6, and 4. In this next one, we've got 3 here, 3 here, 3 here, 1, 2, 3. Wow, this one's a mess of them. Oh, they're all odd. Check that out. Okay. So, let's go here to here. That goes 4 and 4. Here to here. That makes this 6 now. And this 4. And here. That changes that to 4 and 4. Last one. Okay. This is odd. 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 Okay. I'm going to try to use lines that already exist here, if at all possible. Okay. So, let's see. First thing I'm going to connect, these two. Again, if you didn't connect these, that's okay. That's 6 now, and this is 4. Connect these two, that makes this 4, and this 4. Now, these last two aren't quite as easy because there's not a line that already connects them. So we're going to have to kind of do that corner thing here where we go in and out. That makes this 4, this is 6, and this is 4. And that is the end of section 5.7 and the end of chapter 5.